Hello, travelers. We are here at Nuclear Museum of New Mexico. Oh, wow. That's the model.
Yeah, I'm the model, the nuclear.
Walang suklay. Kala mo maganda. So we're here in out. This is just like about 10 minutes drive from our place. It's Albuquerque flag, that one, and then that's the American flag, CR. Look at this teacher. She's trying to steal something from the museum. 30. That's in dollar, not in peso. She's thinking that $30 is just so cheap. Let me see. Let me see the design. There's a lot of NASA design in H&M. So those are the other teachers out there. Look at your hair. Oh, you're so messy.
Shut up.
This is the welcoming floor of the museum, the periodic table of elements. So the first one is John Dalton. Also have Dimitri, Mercury. You have Albert Einstein, William Conrad, Sir Joseph or J.J. Thomson, Ernest Rutherford. These are those pathway to discovery. These are those guys. Like students always ask who discovered this one because this makes our life complicated. These are the people that you need to blame. FDR, Franklin D. Roosevelt. This is the letter that Dr. Albert Einstein made for FDR. By the way, for those who didn't know it yet, we are here in the National Museum of Nuclear Science and History in Albuquerque. It was founded since 1969. We have this sense how this kid is playing with the element factory game. It's really cool. This is Hitler. So if you don't remember, Adolf Hitler, yes, the first spokesman of the Nazi Party in the early 1920s. Yep, and this is the Jim Sanborn Critical Assembly. Like this is how it looks like when they're doing their projects and everything. So the Secret of Los Alamos 1944 and installation by American sculptor Jim Sanborn. So this is how they planned all this atomic thing. They even have the Coca-Cola a long time before. Look at how the bottle of Coca-Cola evolved from being transparent and just plain white. Supportahan natin kasi siya yung nagbayad ng entrance fee. $15 din kaya. This is how they plan. Look at this Chicago pile. I think this one is made of, yeah, this is already made of Lego. This is the modern, the Northern M9 bomb site. Daylight bombing. Look at the boots. This is their state driver's license that was issued in Los Alamos during 1944. It somewhat like looks the same way, the same one with the the new state licenses that they always provide with the kids. And then there's this identification. That's how their ID looks like. It's simple, but it's a lot of pain, a lot of war, a lot of destructions. Example of the atomic bomb. This is the one that they use in Japan, Hiroshima and Nagasaki. A replica of the nuclear weapon that they use. This is how a limousine looks like. The Trinity flag. This is it's all torn out. This is the 48-star American flag flew over Trinity Base Camp on July 1945. Take note, this is only 48 stars on it. So this is the target site. This is where they targeted the bomb. Look, it's so fascinating, but whenever I see all this, like personally, whenever I see all this kind of bombs and missiles, it's terrifying. It brings me back to the time where everything was so chaotic, like all those bombings and everything. So this is the battleship that they use. Look how huge. So if you're gonna compare humans, they just look like that.
Uranium capital is in Grants.
Grants in New Mexico.
They have a lot of uranium there. That's why they made the atomic bomb in Los Alamos, because it's just close.
Exactly. If you remember, centrifugal force plays a powerful role in helping to separate three uranium isotopes inside the centrifuge. So heavier U-238 isotopes will move to the outside, while the lighter U-235 will stay closer to the middle.
Give it a try. Turn the hand trying to spin the disc. Answer which bomb was to the edge. Oh yeah, the light one is the lighter. Oh, blue. The blue one is the lighter isotope.
And this is, what's this for? Yeah, this is the U-235, which is the lighter.
Grab the sides of the maze and tilt it. Tilt!
Ah, okay.
Tilt in any direction to try to navigate the marble into the hole.
Oh, jeez. So we're gonna go to the exit. We're gonna go that way, one that we've been before. You see the submarine. It's just like the top part of the submarine. That's how it looks like. It's huge. The war planes that they have.
So ako nag-ask you, what kind of glasses ako?
Nag-ingon mong good ko.
Try to.
Ilang gig kapatid ng bungol pag ka. Those are the tanks. Let's try to go closer. Get closer and then let's read the description. U.S. Air Force. This is the one that is attached in the Hustler. I get it. This is a Hustler pod, which is a combination of fuel and weapons pod developed for U.S. Use on the B-58 Hustler airplane. So the pod provided a means to deliver thermonuclear weapon and carry extra fuel, and the pod, which is attached to B-58 Hustler, is depicted in the photograph. So that is how it looks like. This is the pod,
Nara siya kadako.
and then this is the plane. So the top part of it, that's where they attach it into the plane. Wow. We're gonna go take video with our science coach from our school. That's Mr. Chipri, the coach for MAS.
The big guy.
We call him the big guy.
Look how big he is.
Yep.
Just to compare how big he is with this little tiny girl in here. This is the plane. Look at the plane, how big it is. And then this is how it looks like if the submarine actually submerged underwater. This is the only thing that you can see from above. And look how big it is. Like whenever I watch it in the movie, I thought like it's just like so it's not that big. But right now, realizing how big it is, like it's really huge. I'm the queen of the world. It's the king of the world. We're gonna look at the telescope and we're gonna see how it looks like.
Hi there. Did you get some glasses? This is a way you can look at the sun directly without hurting your eyes.
Can I remove my glass?
I put it right
And
over
then-
the top
And we can look at the sun
directly.
directly? Oh geez, it's so cool. So nice.
So that's what the color of our sun is. Did you look through the other telescope yet?
No, not
Okay.
yet.
That telescope is looking at hydrogen emissions from the sun. So we're looking at one wavelength of light, but you're going to see red. So our sun isn't red. It's actually the color you're seeing here.
What makes it like I can't see anything if I'm not gonna look at the light? I mean the sun, like the light doesn't get through here.
That's
It's just
good.
like what's with this glass?
You're looking at something at 6,000 degrees Celsius.
Oh,
Okay, so you could do welding with them, except they would catch fire. But it's temperature dependent. So, and the sun is fairly close to us, so you're able to pick up its actual color.
and it also like blocks the ultraviolet rays.
That's what the silver part is.
Oh, this one, like the silver part blocks the ultraviolet rays, and then whenever you look at the sun,
Yeah.
so this is how it looks like. Like the sun really looks like this. There you go.
So in this instrument here, what we're doing is looking at the light from the sun. We're able to spread out the different colors of the rainbow here. Okay, so what I've got the spectroscope looking at is yellow light, and trying to figure out what elements on the sun actually produce the yellow light. So the lines that are the thickest are coming from the element sodium. So I've identified the element sodium on the sun by what we call absorption lines, or the black lines in the spectrum.
This is
Oh,
called
yeah.
spectroscope.
This is a spectroscope, yes.
So it identifies the
And I'm
colors
a
of the sun,
spectroscopist.
and it's
I'm the guy
yellow.
who uses the spectroscope to look at light.
Look, it's
Quite
yellow. So the sun's color is yellow.
That's pretty good.
So the thicker the lines that you see in there, the more of that stuff
Excuse me.
there is.
Excuse
So in this case, sodium has a pretty thick line. So come on up.
Oh.
Yeah, you want to get your
Kailangan
eye
ko.
going down.
What makes the color turn into black or blue or black or red?
Well,
Depends on the thing.
This is above your ability to see. Down here is below your ability to see.
Oh, I
So
see.
the wavelengths are so far apart that humans just don't see that part of the spectrum. So visually or optically, the only thing that we can see from the sun is something around 418 nanometers, or 4183 angstroms. down to about 656. Yeah, we're right on the. This is 656 here. Almost 700.
Hello, can we try?
Okay, before you do, let me just make sure we're in the right position because it's moving fast.
I bet it's red.
Yes, you
I
can
see it's red.
It is red. We're looking at hydrogen.
Oh, so this is how it looks like in the sun?
Yes.
It's red. So we're looking for the sun's magnetic fields or the sunspots?
What you're looking for is there's a bunch of these fuzzy hairs right up here and some over here. Those are clouds. Then there's a little tiny sunspot right about here, and it's surrounded by a bunch of blood yellow area, and that's a sunspot that's flaring.
Sunspots or sun flare. So this is how it looks like with the sun's magnetic fields.
Yes. And
Sun
that's-
also has a magnetic field.
Oh, yeah. It's pretty chaotic, isn't it?
Yeah.
Turn it over. That's our magnetic field.
This is the Earth magnetic field, which is pretty normal. We have
Yep.
north and south that pulls out the energies or the magnetic fields. But the sun's magnetic field is so chaotic that we don't even identify which one is the north,
Exactly.
which one is the south.
Yeah, there's many north and south, really.
So complicated.
The fuzzy hairs sticking out?
Yes.
Okay, how about the sunspot?
That's the corona, the outer part.
No, these are just clouds. What you're seeing are not flares. The flare is this little yellow part up here. What's sticking out that looks like this are just clouds.
What makes this one different from the other regular telescope?
Well, if you put a solar filter on a regular telescope, you would see this version, which is kind of like your eye.
Oh, this one.
Right. This telescope filters out all the other elements, just looking at one wavelength, which is hydrogen.
Oh, that makes sense. That's why the
and
other one
this is in the chromosphere.
Oh.
Not the corona, the chromosphere, which means atmosphere, where you can see the color.
Yeah. That makes sense. That's why it changes its color. Every time that we do have like eclipse,
Yes.
do you also look at the eclipse in here?
Oh, you can see it, sure.
The solar and the lunar eclipse?
Yes. Lunar, no, because this is the only thing we can do with this telescope is look at the sun.
Oh, I see. So you can use this one for solar eclipse, but not the lunar eclipse.
Lunar eclipse, you look at it with your eyes.
Oh, I see.
You see better than in a telescope.
And it doesn't damages your eyes?
No, because the moon doesn't give off any light. It's all reflected from the sun. Yes.
That's so fascinating. This is how science looks like.
Yes.
It explains
real science.
Yeah.
Yeah.
Which is what
Museum is real science. Yeah.
this is what I like with science. It explains everything.
Right.
Thank you, miss. Bye, travelers. We're gonna leave some MAS charter school. And we're gonna see you for another travel and vacation tours here in the US. Bye.
4 to 6 days later.
You're recording us in this madness.
Yes. I want to add it on my vlog.
I'm like, I love this hairdo right here already.
So nice. I'm so excited to see the finished result of this
It's
hair.
about to be bomb.
Yeah.
This is about to be bomb.
I love it. Oh baby, just look at my hair. And I love it so much. Having a braid hair. Come on. It's so nice. I love it. Hi good travelers. I just want to flex my hair. Look how beautiful it is. I love how my friend just fixed my hair and it looks so gorgeous. See? I love this one too. I like it the way she fixed my hair this way. And then I just don't know if I can carry my head whenever I play volleyball, but I think I can manage this thing. Love you good travelers. Love myself.